Measurements from NASA's Transients Exoplanet Survey Satellite (TESS) have enabled astronomers to greatly improve their understanding of the bizarre environment of KELT 9b, one of the hottest planets known. The weirdness factor is high with KELT 9b, said John Ahlers, an astronomer at University's Space Research Association in Columbia, Maryland, and NASA's Goddard Space Flight Center in Greenbelt, Maryland. It's a giant planet in a very close, nearly polar orbit around a rapidly rotating star, and these features complicate our ability to understand the star and its effects on the planet. The new findings appear in a paper led by Ahlers published on June 5 in the Astronomical Journal. Located about 670 light-years away in the constellation Cygnus, KELT 9b was discovered in 2017 because the planet passed in front of its star for a part of each orbit, an event called a transit. Transits regularly dim the star's light by a small but detectable amount. The transits of KELT 9b were first observed by the KELT Transit Survey, a project that collected observations from two robotic telescopes located in Arizona and South Africa. Between July 18 and September 11, 2019, as part of the mission's yearlong campaign to observe the northern sky, TESS observed 27 transits of KELT 9b, taking measurements every 2 minutes. These observations allowed the team to model the system's unusual star and its impact on the planet. KELT 9b is a gas giant world about 1.8 times bigger than Jupiter, with 2.9 times its mass. Tidal forces have locked its rotation so the same side always faces its star. The planet swings around its star in just 36 hours on an orbit that carries it almost directly above both of the star's poles. Advertisement KELT 9b receives 44,000 times more energy from its star than Earth does from the Sun. This makes the planet's dayside temperature around 7,800 degrees Fahrenheit 4,300 C, hotter than the surfaces of some stars. This intense heating also causes the planet's atmosphere to stream away into space. Its host star is an oddity, too. It's about twice the size of the Sun and averages about 56% hotter. But it spins 38 times faster than the Sun, completing a full rotation in just 16 hours. Its rapid spin distorts the star's shape, flattening it at the poles and widening its midsection. This causes the star's poles to heat up and brighten while its equatorial region cools and dims, a phenomenon called gravity darkening. The result is a temperature difference across the star's surface of almost 1/500 F 800 C. With each orbit, KELT 9b twice experiences the full range of stellar temperatures, producing what amounts to a peculiar seasonal sequence. The planet experiences summer when it swings over each hot pole and winter when it passes over the star's cooler midsection. So KELT 9b experiences 2 summers and 2 winters every year, with each season about 9 hours. It's really intriguing to think about how the star's temperature gradient impacts the planet, said Goddard's Knicole Colón, a co-author of the paper. The varying levels of energy received from its star likely produce an extremely dynamic atmosphere. KELT 9b's polar orbit around its flattened star produces distinctly lopsided transits. The planet begins its transit near the star's bright poles and then blocks less and less light as it travels over the star's dimmer equator. This asymmetry provides clues to the temperature and brightness changes across the star's surface, and they permitted the team to reconstruct the stars out of round shape, how it's oriented in space, its range of surface temperatures, and other factors impacting the planet. Of the planetary systems that we've studied via gravity darkening, the effects on KELT 9b are by far the most spectacular, said Jason Barnes, a professor of physics at the University of Idaho and a co-author of the paper. This work goes a long way toward unifying gravity darkening with other techniques that measure planetary alignment, which in the end we hope will tease out secrets about the formation and evolutionary history of planets around high-mass stars. TESS is a NASA Astrophysics Explorer mission led an. Additional partners include Northrop Grumman, based in Falls Church, Virginia, NASA's Ames Research Center in California's Silicon Valley, the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts, MIT's Lincoln Laboratory, and the Space Telescope Science Institute in Baltimore. More than a dozen universities, research institutes and observatories worldwide are participants in the mission. Thanks for watching. Do you like my video? Then show me your love by pressing like button. Please subscribe my channel and hit bell icon for new technology updates. Bye bye.